Here we have an example of a probability problem with a discrete random variable. In this case, the variable is D. It represents the first digit in a data entry. Kind of interesting situation here. The first digits of data entries in most real-world data sets are not uniformly distributed. The most common first digit is 1, followed by 2, and so on, with 9 being the least common first digit. This phenomenon is known as Benford's law. So in this problem, we're figuring out what is the probability that a randomly selected data entry has a first digit less than 4. Little summary here, what is the probability that the first digit is less than 4? What we need to do here is add the probabilities for the outcomes that are less than 4. So we need to add these three probabilities because these have a first digit of 1, 2, and 3. And those are the outcomes where the first digit is less than 4. So the probability of getting a first digit less than 4 when we randomly select a data entry is 0.602. The American Community Survey is completed by the U.S. Census Bureau to obtain information about households in the U.S. One variable of interest is how many people reside in each household. Vacant households were recorded as having 0 people. Based on data from 2014, here is the partially completed probability distribution of H, the number of people residing in a randomly selected U.S. household. Find the missing probability in the table. So we need to find the probability that H equals 0. We know in a probability distribution that the probabilities must add up to 1. So we can add up the probabilities that we do know and subtract that sum from 1, and that will tell us what's left for the last probability in this distribution. So these 4 probabilities, these 5 probabilities have a sum of 0.88. So when we subtract that from 1, we get a probability that H equals 0 of 0.12. Hugo plans to buy packs of baseball cards until he gets the card of his favorite player. But he only has enough money to buy at most 4 packs. Suppose that each pack has probability 0.2 of containing the card Hugo is hoping for. Let the random variable x be the number of packs of cards Hugo buys. Here's the probability distribution for x. Find the indicated probability. So we are wondering what the probability is that x is greater than or equal to 2. X is greater than or equal to 2. Well, that includes 2, because x can equal 2, that's included here. Or it could include 3 or 4. So to find the probability that x is greater than or equal to 2, I need to add these 3 probabilities. So we get a probability of 0.8. Another problem with baseball cards here. Here we want the probability that Hugo needs to buy fewer than 3 packs. Okay, so fewer than 3, well, that would include only needing to buy 1 pack, and it would include only needing to buy 2 packs. But it would not include needing to buy 3 packs because 3 is not fewer than 3. So to find this probability, I need to add 0.2 and 0.16. So the probability that he needs to buy fewer than 3 packs is 0.36. So to solve probability questions with discrete random variables, we use addition or subtraction to figure out our probabilities. Signing off.